we'll get started with lightning talks. Give it up for Dustin Kirkland.
Howdy, howdy. I'm going to demo overlay root for you today. It's something that Scott Moser helped me with in the last cycle. This is an Ubuntu 12.10 image in Amazon, launched 2 or 3 minutes ago. In every default 12.04 image, we now have this package called overlay root, and there's a configuration file, overlayroot.conf. I'm going to come down to the end of this configuration file, and I'm going to do 2 demos, one using tempfs as the backing store, and the second one an encrypted, de-encrypt volume. So I'm simply going to type tempfs in the overlayroot.conf file and reboot this system. It'll take a second for this to finish. But overlay root is a combination of 2 different pieces of technology we've got in Ubuntu, and it's really the same thing we do on a live CD, where you've got this read-only image, which is the live ISO itself, and then you've got this backing disk image, which might be tempfs in memory or can actually be a persistence file. We've taken that same concept and applied it to cloud itself, where the cloud image, the AMI, is a public read-only, well-known thing, that we publish. It's really what you change inside of your image that's different. Sometimes you want that just stored in memory so that it's never actually written to disk. In other cases, what you're writing to the cloud itself, you actually want to protect. You want to protect it from your cloud hosting provider. You may want to protect it from someone else who's using that disk image at some point later. We should have booted by now. It's supposed to come right. Okay, here we go. It's timed out. It does that, and then voila. Okay. So now if we type mount and we look at what's happened here, we'll see that the usual dev xvda, that's our root volume, it's mounted read-only, actually. It's a ext4 read-only file system. That's the stock Ubuntu image itself. We've also got a tempfs root that's mounted on media root read write, and that's your tempfs, and then we've got this overlay root, which combines the 2. And that actually has a lower dir of our media root read-only, and then we've got our upper dir of our media root read-write, which is in the overlay root. And we can make a bunch of changes in this file system, but the changes only get written to the tempfs. So I'll just write dmessage to a dmessage.text, and so now we've got a dmessage in here. But if we go into this media root read-only file system, this is what the file system actually looks like in a read-only mode. If I try to touch something here, it's a read-only file system. But if I go into the root read-write, we see the differences. In here we see everything that's changed, which includes var log, var lib, our temp, anything that's changed in home or etc. Or boot. So in home Ubuntu, here we've got our dmessage.text, which is our difference. This will be removed on reboot. So there's actually an overlay root chroot command, which makes your read-only file system read-write, and you chroot into it, which is where you need to make changes if you want them to persist across reboots. So now I'm going to come into here and say I want to encrypt this, dev equals dev xvdb. And we'll reboot again. I'll spare you jeopardy this time. But while this reboots, we'll take a quick look at what the architecture actually looks like. So there's this overlayroot.conf and this union file system that's spreading basically unioning the 2. I don't know if overlayfs is in the upstream kernel yet, but it sounds like it's getting closer there. We used AUFS previously in Ubuntu, but this is, I think, really cool technology, especially if you're doing something where you're testing in cloud images. You want it to look the same every time you reboot, or you want to encrypt any of your differences that actually happen. Key management is a bit of the trick, right? We generate this large random key at boot time. We need to improve entropy in cloud instances. That's a whole other topic that we could talk about so that we get good keys. The key you can specify, there's a couple of different ways you can specify the key. It's generated automatically at boot time and written to a temp file in /dev in a temporary file system. You can specify it in as a kernel parameter. I think I'm done. Come see me if you want to see the encryption demo as well. Thank you.
Okay. All right. So in the 2 weeks before UDS, I spent 2 weeks in Ghana. There we worked with a nonprofit in Pittsburgh who ships out Ubuntu and Edubuntu desktops. And we also worked with a nonprofit in Ghana on the ground, which works to get ICT out to schools that don't have computers. So, which clicker am I using? Okay, so when we got there in Ghana, the computers didn't get there. They got stuck in the port for most of the time we had our trip. So this is apparently pretty common for Western Africa. So we had to readjust our schedule some. One of the things we did was visit one of the past deployments that these nonprofits did. We shipped 5 desktops or laptops to the school, the Street Academy. When we showed up to check in on them, 2 of them had been reinstalled with Windows. The rest didn't really boot. So we're not sure what happened. But that taught us really early on that training was going to be essential to these deployments. Because if people don't know how to use the computers, they said they installed Windows because they didn't know how to add a printer. So we quickly put together some training materials. And then here's a picture of at the Street Academy, the teacher who came along with us, Nancy, she was training some of the people, and I was helping develop the Linux side materials. We also met with the Linux users group in the capital, Accra, and they're helping with the deployments on the ground. So they're working with the NGO there to support the administrative side of these deployments now. So it was really cool to get to meet them. Since we were in Africa, we saw Ubuntu signs. That was fun. Do you want a house? This is another school we visited. It was a Right Way International School. There are about 190 students at this school. And as you can see, this is one of the classroom buildings. They're open air, they don't have doors, they don't really have windows, they're kind of shack-like. And the students learn ITC by, there's a chalkboard with a keyboard drawn on it. Since ITC is part of the curriculum, the students need to learn about how to use computers, and they learn it by a teacher explaining what a keyboard is or a mouse. So they have textbooks, and they have keyboards drawn on screens, and sometimes they go to a field trip to go see a computer, but they don't really get to use them. We couldn't deploy to this school because they don't have electricity, but they're building a new building, so hopefully then. We also got to meet with some key people on the ground in Ghana. This is when we met with Estelle, who's the leader of the Google push in Ghana, where I got this cool Africa t-shirt of Google. So we also met with someone from USAID who does a lot of aid work. We met with a couple of government officials who were trying to help us. We were all operating out of hotels and people's homes, so this is just one of the pictures of our late night hack sessions. We were developing training material, and I was fixing the Edubuntu installs because we had some proxy issues with some of the software installed. This is when we went up to another town where we did another deployment. Same thing happened here. A couple of the machines had been reinstalled with Windows. So again, we did a training session with the teachers up there. So this was a Saturday morning. They all came out at 8:30 a.m. We saw monkeys, which was like the best thing. And Ghana is a huge, they have a huge problem with e-waste. So we partnered with a recycling program to make sure the computers we ship over there don't end up as in these vast piles of waste that you end up having children going through and burning copper and doing other things to try to get money for their family to, when they sell the materials. But it's dangerous and it's not good. So we made sure our computers wouldn't go there. And this organization we partnered with, they also go down to these dumps and they train people how to properly handle the materials so they don't get hurt and so they can get the most money out of the materials they provide. The day I left was the day that our computers were finally released from the port. The rest of the team was going home the next day because I needed to come here, so I left a day early. So after I left, they were able to deploy 10 of the 100 computers, and this is Nancy again. She's doing training after they set up those 10 computers. And so the Africa ICT Right, the NGO on the ground, they're going to be continuing the deployment and working with us online to finish it. So that's it.
Okay. Wonderful. Hi, my name is Chris Argus, and today I'm going to talk about data mining at Ubuntu. So I did this project for my master's report this summer, and the premise was we generate a ton of data in Launchpad for Ubuntu bugs, and we have a ton of bugs, but we only have so many people to fix them. So last UDS, I saw a lot of presentations and things like that where it's, we were looking at this data and we're trying to figure out what we can do with it. And even in this UDS, all the really awesome work with their errors.ubuntu.com and all these things like that, really cool stuff. So the premise was, let's use that data and work more precisely. So the other cool thing with this project was I got to visualize a lot of this data, and I saw like how awesome of a job that we're doing fixing a lot of bugs. So, oh, I'm sorry, can you not hear me? So what was done was that I downloaded all of the public Ubuntu bugs and put them into a database. And then I used a programming language called R, which is a GPL language, and to produce graphs and explore the entire data set. Then I actually used data mining techniques to predict certain features. And the two features that I chose for my report were predicting if a bug will be invalid based on the inputs, and predicting whom should work on the bug based on historical, who's been assigned to those bugs and fixed them. So for the data, I downloaded 600,000 bugs. I downloaded 700,000 bug tasks, and that covered dates from 2004 to 2012. So here is the history of Ubuntu bugs here. And so that blue line shows the current open bugs at that time and date. The axis here on that show the different releases here from all the way up to Quantal, although that looks a little messed up. The red line here is actual closed bugs, so this could be invalid bugs, fixed release bugs, etc. And that green line are all the fixed release bugs. So we're doing a lot of work. That top there, that number is 400,000. So pretty cool stuff. So I also wanted to look at, how do these relate to each of the series? So what I did was I took the bugs that were targeted to a particular series and graphed it. So here you see a whole mess of data here, but it's showing, but each of these colors is a different release, and it's showing the activity per release. So you can see we're targeting more and more bugs as we go for newer releases. But you see the count is only about 1,500. So if we actually try to plot the total untargeted bugs, you won't see this data anymore. So I had to plot it logarithmically along the y-axis. So the total untargeted bugs is an order of magnitude larger. So this was kind of useful to see some of that data, but I also looked at how much are we doing actually during each development cycle. And you can see we're doing more and more work. We're filing more and more bugs per release. And then this is actually showing us how much we fix it after the release, how fast those bugs go down within the first 6 months. So this is all great. These are great visualizations, and I think it'd be cool to even make these more interactive in the future, like web interfaces or web stuff. But I also looked at histograms of bug states. So on average, it takes about 163 days to fix a bug. It takes on average 75 days to go from created to assigned. Now, if you look at these graphs, you actually have a very long tail. So some bugs are open for a very long amount of time, but we actually solve quite a few bugs in a short amount of time. The colors on here show the green is fixed release and that gray is invalid or won't fix. So we spend a lot of time with invalid bugs too. And so that was number one premise that I saw is how do we predict those invalid bugs? The second thing is it takes quite a long time to assign somebody to a bug. So if that 163 days, 75 of those days are spent actually looking for somebody to work on the bug, maybe we could find historically who's fixed these bugs and try to suggest that they work on them. So those are the hypotheses. Oh, I could use that. Well, here's a bunch more data that's going to be, actually explains my results. So using techniques such as naive Bayes, clustering, or support vector machines, I was able actually to predict an invalid bug with an 83% accuracy with the data set that I had. Excuse me?
Did you quarantine some of the data so that you could actually measure how well you were doing?
Yeah. So with a lot of like data mining stuff, what you do is you create you partition your data into a training set and then a validation set. So that's what these numbers here on the bottom is. Actually, I changed the training set to make it larger and larger, but the problem is it would completely slam my computer. So this is a good big data problem that we could probably apply later on. Great. So it was awesome. Thank you very much. Oh.
When can we get a bot that starts auto triage? Button map to the plenary.
Does sound work? No. I didn't expect it to work, so. One of the things I've been working on for this cycle was getting the Quantal stack in, also a little bit on the hybrid graphics work, and also a little bit on getting the Quantal XArc stack back on Precise, and also some work on Wine on the side. So the thing I was thinking about, why not combine them all in one presentation and show what I've also been working on. So yeah, this is Half-Life running in Wine in Steam on Ubuntu Precise with the Quantal stack with hybrid graphics. This is a machine that has an NVIDIA card and an Intel card, and it's currently rendering on the NVIDIA card. So I thought I'd give a demo, but it's going to blow up probably. It's not clicking, is it? No. No, it's already blown up. That's cool. Yeah, it looks that way. Oh well, thanks for your time.
That works, right? All right. Wow. Okay, so I'm Stefano, I'm from Ask Ubuntu, and I'm going to show you the review feature of Ask Ubuntu. Because at this point, most of you hopefully have an account on Ask Ubuntu, and if you haven't, go sign up now. And if you have, you can start reviewing, you can start moderating, because the site is run by all of you. If we look at the review feature, which you find on askubuntu.com/review, you can check out first post, so that's people who answered a question, which was their first post, close votes, late answers, low quality posts, which are automatically assessed by the system. I like to look at those. So if we have a look, there's a little introduction at the top, which you can hide if you know what you want to do. But you can see 4 buttons at the top: looks good, edit, delete, and skip. So if we look at the question and the answer, what does it say? Well, this is actually a comment. So I'm going to delete that. Yeah. Well, and you can be brave. That's no problem. So where are we? The second one. This is commentary on another post. So that's all you need to do. And right now, you've helped clean up the site, raise the standard of the quality of the questions on the site, and benefited everybody who's going to do a Google search for this. So, please do that. That's it.
Delete something. Really?
No, dude. That's display. We have HDMI up here? To the right. I don't. Let's kick you back to the back. Aurelian, can you go now? All right. Let's see.
Okay, apply. Are we on yet? No, maybe. Yes, it looks like it's working. Let's even go to this way. Apply. And we should be, hopefully, yes. Okay, good. So, as you know, the Kubuntu community is very well organized. So at 12:30, someone came and say, hey, we have to do something for this lighting thing. Okay, what can we do? So since Jonathan, oh, I broke something. Jonathan already announced that I was about to present something exciting. I thought, yeah, I could do that. So let's see if the thing is actually working. It's not as good as I want it to be. What's wrong with this thing? The joy of running master. Things have died. It's still early and we are organized, as I said. What's wrong with you, thing? That's fine. Isn't it nice? Oh, I see myself here. Oh, yeah, you got something. So here comes an early version of Homerun with weird rendering issue, which should not be there, but nevertheless. So Homerun is a new launcher I've been working on for KDE. If you think that it looks a bit like the Dash, you might not be wrong. Let's admit it, okay? There are good ideas. We stole them. But we try to do our things anyway. So you can, wow, it's really broken. You have, basically the idea is that you have several tabs, as you can see here, and they should change when I click, but they do not. Okay, now I say you're impressed. And you have also several sources. That is, a tab is made of several sources, like favorite application, favorite places, recent documents. And I'm pretty sure if I click there, it's not going to work, but it's not. Okay, so I think you will have to come to see me so that I can do a proper demonstration without hardware issue. Well, I think my presentation is still. Sorry for that. Oh, bada boom.
Think good thoughts, everyone. We can make this happen.
Hey. Okay. So I'm going to talk about. Let's see. Okay. So I'm going to talk a little bit about how to make Java applications running on both mobile devices, Android, and on a Ubuntu desktop.
So basically, I've been working with the OpenJDK team, and I've been looking into ways to access hardware acceleration on using Ubuntu. And by default, when I started this year, I was trying some nice demonstrations, and I tried to get it running. And when I got it running, it was not really what I expected. So, for example, running one triangle on the screen generated really poor results. What's like this? Not really fun to look at. So, yeah, there's the triangle. Okay. So we worked it out, and noticed that the MISA drivers by default told the system, told us that the drivers was actually hardware accelerated, but they were not. So we got fooled, and when we figured this out, we started to probe the system for all available installed libraries, and then was able to access the hardware acceleration, and now we have a nicer moving triangle. And then we could move on and get some basic functionality working, like the standard OpenGL test case. That's to have some spinning gears. Yeah, yeah, like wood. And so going on, so we started to think, what if we could make existing application running on a mobile device? So we started to create a way to get OpenGL code running on OpenGL ES. And that's what we are now. So now we can run Quake 2. Yeah. So let's quit. Yeah. So I can say this Quake 2 is actually running on the Nexus 7. We tested it during UDS. So we released the YoGAMP YoGL RC11 this night. So you can get it from yogamp.org. And it works on Ubuntu desktop, OpenGL, and mobile OpenGL AS. And you can also get it run on Android. So thank you very much.
So, hello everyone. I'd like to announce the long-awaited winners of the autopackage test competition that we had going on during the UDS. I mean, quite expectedly, we all have been busy with other stuff, so we didn't get like 150 contributions, which frankly I was quite happy about, otherwise you would have never been able to review them. So we got, come on. So we got 11 contributions from 5 different people. Namely, Daniel Holbach, Michael Vogt, and my humble self each sent 1 test. And then we had Benjamin Drung sending 2. And then we have, sorry for getting the name wrong, Rafael Sislak, who did not send in 3, not 4, not 5, but 6 autopackage tests. So this is... Then, of course, I mean, the unstoppable Rafla is obviously the clear winner here. So please come down and get a round of applause and your bag of awesome Ubuntu awesomeness. And, of course, there is a special present, the unique Daniel Holbach hack. So, yeah. And Benjamin, please come down too and get your round of applause. Thank you. So I just want to quickly show the kind of test that they wrote, and it's really like everyone can participate in this. It's not really rocket science. So Rafael wrote a lot of library tests, which make sure that we can build a very simple basic program like this is GTK Pixbuff. Just make sure that the very basic functionality of compiling something against the library, linking against it, and running it works. And this might seem simple, but it already helps us to figure out stuff like, are your package config files installed in the right place? And
Are you plugged in?
oh, I'm sorry. Someone tell me. Right. All right. So, as I said, like he just tries to build a very basic C program for that particular library against that and make sure that we can run it. And there's a whole lot of stuff which can go wrong in that case already. Like you forget to ship a header file, the package config file is wrong, or misses a dependency, and so on. So this is useful, really. And likewise, Benjamin integrated existing upstream tests so that we can run them against the system installed package. So like the actual test would look fairly easy. So you just basically call the upstream test. You had to make a couple of adjustments to convince the upstream test that they run against the system installed version and not the local build tree. But yeah, so this is the kind of things which we are looking into to get like the broad, like a lot of the Ubuntu archive run tests. I think I recently heard that about 40% of our packages in the whole archive already have some kind of test, so let's integrate them all. And thanks for everyone who participated, but let's not stop here. Thank you.
Right. My name is Jussi Pakkanen, and this is mostly a condensed version of a couple of blog postings that I have on my development blog, the address of which is over there. And the goal of this talk is talking about compile speed. And usually when you start talking to people about compile speed, you get one of these two responses. Either like, okay, so this is the way it is, or that C++ is terrible and therefore you hit slow speeds and you should rewrite your code in G-object or something like that. But the question is this actually true and can we do something about it? And I'm going to show 3 things which can be done. It's a really simple thing to do and you can get nice performances out of that. Right. Now, the first thing is that there is a replacement for make, which is called Ninja, and it's made by Google developers who are working on Chrome, and they got tired of make being quite slow, so they wrote a replacement. This is not in Ubuntu yet, it's in the Debian new queue, and hopefully it will get into Debian soon, so it will come back, you just build your own. And for this test, I took the CLang compiler sources, which is a fairly big amount of code, and you compile it with this Ninja and make, and then you run the compile command again. So there's no changes, it just checks how long does the build system take to check how long that nothing has changed. Make takes 7 seconds, and Ninja takes 0.1 seconds. And this is a noticeable difference when you are working on things. You're going to have real fast iteration. Ninja compiles faster, but only sometimes. There's some sort of thing which I haven't been able to nail down why that is. But you should really, so if you're using CMake, you just use the Ninja backend generator. It works today, it's fine. If you work on Chromium, the JIP thing has the same as well. For other tools, you can't really change because it's tied to make. Another thing is that there is a replacement for the linker. So the linker is something that actually takes quite a lot of compile time. And the standard linker it's fairly slow. It's an old code base and so on. And the new people started writing a new compiler in C++, I think, which is called Gold. And it's in the repository. You just install that package. There's the thing that when you install that one, there's the user bin LD is a sync to the actual linker. This is not in update alternatives, but you just fix it yourself and fix the symlink to point to the old linker and then just manually say, okay, I want to use Gold for this particular project, because Gold is a bit stricter and it has some issues and it might not be the best thing to have as a default linker. Then there's this one, which is precompiled headers. A quick show of hand, who has used precompiled headers? Okay, so this is very, very tricky to get right because you have to, it's like a Formula 1 car. You have to work with it a bit, but then you can go 300 miles an hour. Just, be careful. Okay, so I did an experiment, and I took the Scribus desktop publishing application, which is fairly large, and I did compile it with all this new stuff, and I used this machine here. It has about 4 cores, relatively fast. So when you compile it out of the box, it takes 11 to 12 minutes. If you use Ninja and Gold, it takes 9 minutes, and then you add pre-compiled headers to that, and it's 7 minutes. And this is 40% time saved on compile speed. I did an experiment on Unity for one module built, and it also took down about 40% of the build time. So if you have large C++ code bases, this is something that you might want to look into. For CMake, it's relatively simple. There's a UCS for the merge requests to Unity. There's one which has the module for using this. It's fairly simple to use. It's not totally polished, but you can. If you're using auto tools, you are pretty much on your own. But basically, the thing to take home is that build speed is an engineering problem. It's not some like unsurmountable problem that you can't do anything about. Thank you.
We have room for one more talk if you're feeling motivated. Yeah, come on down.
Hello, my name's Alan. You may remember me from failed laptop talks in the past. Let's do another one. Mirror displays, hit apply, stuff appears. Yes. Okay, so we had a couple of really good talks, really good sessions this week about the Nexus 7 ARM devices, saving power, trimming down the desktop so that we can minimize the amount of memory used and get the maximum amount of power out of our batteries. But I'm carrying a Core i7 with a giant battery, and I kind of care less about that kind of stuff on my laptop, much like most end users. So I install all kinds of rubbish on my machine that eats up my CPU and kills my battery, and I just wanted to show you 2 of them. I often find myself browsing popular internet blogs such as OMG Ubuntu and I Love Ubuntu and Ubuntu Vibes, and I found a couple of interesting apps. The first one I wanted to show you was Variety Wallpaper Changer. I've never been a big fan of wallpaper changers. I usually stick with the default fruit salad or whatever this thing's called on the desktop. But with Variety, I've discovered new awesomeness. It has a little indicator thing here, and there's loads of preferences. And what you can do is get it to go off to the internet, get loads of stuff for you, and store them on your machine, and then display them on your desktop. You'll notice I've got one of them disabled while this is being filmed. There's loads and loads and loads of options, but the thing I tend to do is have it set on playback, where every few minutes my wallpaper changes and keeps my wallpaper nice and fresh. You can also manually just fudge it onto the next picture. I have no idea who these people are. It's a picture that came from the internet. You can also hold your middle mouse button over the Variety icon and then scroll the mouse wheel. Food, brilliant. And just every time you nudge forward, nice landscapes, weird pictures, you get all kinds of good stuff. So that's moving on. That's the first one, is Variety. The second one, we've been talking a lot about people having portable devices, and Android is a very popular portable operating system, and one of the features that Android has that lots of people seem to like is live wallpapers. So there's another app which is Live Wallpaper for the Ubuntu desktop. And you can get that from Launchpad, and there's an indicator thing here as well. And yeah, you just turn it on, and you get a animated wallpaper, which is quite nice. Yeah, look at that. I didn't make this. I'll accept the applause by proxy, though. And there's also this one as well. So yeah, it's a giant rip-off. So it's quite good fun. But the other nice thing you can do with this, of course, this also has a load of settings. You might not want to have the star field in the background, so you might want to have a picture. You can set a background here. So if you just turn the background on, you get colors in the background, and you can set the gradients. Alternatively, you can go and find another picture. I've got a picture here. That one will do. Thanks very much. Thank you.
Oh, there's a million connectors here. Okay, how does this? Oh, there we go. Oh, nope. Why doesn't that fit? Okay, well, I guess we'll just do this windowed then. So I'm just going to talk a little bit about editing photo metadata, primarily with Python. So I'm the author of a program called Gotten Geography, and what this program is it just lets you put photos on maps. It's very simple. You can just drag and drop. That's not really what this talk is about. It's just kind of one of the technologies that I needed to make this application. So it's written in Python, and I needed to be able to edit photo metadata, including like GPS coordinates and that kind of thing. And in Python, the most popular library for doing that is called pyexif2, which is just a basic wrapper around libexif2, which is a much more mature library. And it has a really big problem, though. It doesn't support Python 3, which is critical because Python 2 is old, and we need to get rid of that. So I needed a solution to be able to port my application to Python 3 and still be able to edit these photos. And what I discovered was that the wonderful people from Yorba had this library called gexif2. And gexif2 and pyexif2, they both wrap around the same libexif2, so very identical in their feature set. But gexif2 only works, or at first it only worked in Vala. And so what I did was I came along and I added Python bindings to gexif2. So now, thanks to the magic of G-object introspection, you can actually access this from any programming language. It's not specific to Python. You can get it from Perl, Ruby, anything you want, really. But the Python bindings are the most polished at the moment. So basically, this is the new structure here. So the gexif2 bindings that I made equally support Python 2 and Python 3. So it's very easy. You can port your application first from pyexif2 to gexif2. And then once you've got that, there's very little else standing in your way to get your application into Python 3 territory. So I just have a quick code listing here. Now these two examples are exactly identical. They both open a file, add some GPS coordinates, and then save the file. And I'll just try and pull that out a little bit so it's more readable. But basically, so sorry, the left half is with pyexif2. That's the old way. It's very inefficient, and it's not very nice. The right half there is, oh, sorry. The right half there is gexif2, and it's much more efficient, basically less than half the number of lines of code to be able to do the exact same stuff. It's quite a bit nicer, in my opinion. And, oh, that lined up better when it was maximized. There. Yeah, so Python 3, it's the future. Please port today, right now, go. Oh, here we go. So hopefully you should see my screen in a second. We're getting there. Okay, so
We've heard a lot about Juju, and I'm super excited about Valve finally porting the Steam client to Linux. I game a lot, and it's actually one of the only reasons why I still have this giant laptop, is so that I can play games on a Windows machine. So when I heard that Valve was actually bringing a Linux client, I was really excited. And now that I have beta access to the Linux client, I am super excited. So I decided that, well, I'm going to be playing all these games on Steam. I want to be able to play with my friends. And as a result, I wrote a charm to deploy Steam and all of its libraries of server games in the cloud. So instead of having to do the tedious task of spinning up a machine and then logging in, the typical Juju story, spending a lot of time in forums figuring out how to actually deploy these servers, I can do it now from Juju. And that looks a little something like this. Because these games are very large, quite in the realm of several gigs of sizes, I decided that I was just going to deploy ahead of time. But to get a running Steam server, and I did Left 4 Dead 2 first because that is hopefully going to be the game they port first, it looks something like this. So Juju, deploy, Steam. And doing that will deploy the central Steam library, which is basically a binary that contains all of the game data and how to download and update them. So as a result, I didn't want to make a new charm for every single game, so there is just this Steam charm. But what you can do with the Steam charm is you can deploy other games on top of it. For instance, Left 4 Dead 2. And in doing so, you can then relate the two together, and as a result, you can deploy several of these different types of games on top of one server. So instead of having to deploy a server for Team Fortress 2, one for Left 4 Dead 2, one for Half-Life Source, one for Day of Defeat, one for Counter-Strike, I can actually run them all on the same server by just deploying a series of these together. So Team Fortress 2, for instance, and then adding the relation together so that it knows which server to talk to. So I can say Steam Left 4 Dead 2. And this is kind of what it looks like. Oops, that's not what that looks like. After I deployed and waited several minutes for about 12 to 15 gigs of game data to be deployed on the server, I got an environment that looks kind of something like this. And what I'm going to try to do now is plug my Windows laptop in and then connect to the server in Left 4 Dead 2, and hopefully that'll work. So this is what it looks like in the end. It shows that I have just one server running, this one right here, but I have the Left 4 Dead 2 game deployed on top of that server, which is right here. So it shows me that Left 4 Dead 2 is a subordinate of it. So you could build all these different subordinates that plug into this larger architecture. So Steam has a library of like 35 different servers you can deploy with this one Steam client. And as a result, you can deploy now all of those with these different subordinate charms without having to do all this tedious construction, but also without having to spin up a million servers for each instance of the game you want to run. So without further ado, I'm going to try this. Perfect. It's funny how my Windows laptop can't do this, but the Ubuntu one did it just fine.
My demo had the same problem on mine.
So, yay, Windows. Yes, play it. Excellent. So I'm just going to type in the server IP address from the Juju status, which is Please stand by.
Did you expose it?
Yes, yes. Well, again, I just wrote this a couple days ago, so it's not in the official Charm store yet, but it will be sooner or later, as soon as I make sure it actually confirmed works. But theoretically, oh, you know what? Yes, I am, because I am connected to Steam, so I should have Wi-Fi. Troubleshooting. Yeah, so you get the idea. This will work sooner or later.